Good day, this is Bennett, also known as Jeremiah. Today we're going to debate how to find maximum distance in functions. If you are interested in similar videos, the playlist is found at the end of this video. It is also found right here on the top right of the screen at the suggested video. So, let's begin. Alright, here is the first question. So you're given two parabolas. You're given f at x is equals to 2x squared minus 8x minus 2. And you're given g at x equals to negative 2x squared plus 12x plus 4. And you're asked, calculate the value of x such that the length pt will be maximum. So, first of all, you have to consider the fact that p is a point and t is also a point. So, t has an x coordinate and a y coordinate because it is a point on the graph. So, notice that y is the same as f at x, or f at x is the same as y. So we'll just replace it with f at x. So notice that f at x is this equation. So we will replace f at x with this equation. So we will write everything exactly the same except for this part. So this is gonna be 2x squared minus 8x minus 2. So we always have to write this in terms of its equation. So since p is a point on the Cartesian plane, it means that it has an x coordinate and a y coordinate. So instead of writing y, we will write g at x. Now we will write g at x because notice that before we were looking at point t, and point t is on the equation of f. So because it was on the equation of f, we had to substitute it with f at x. Now point P is on the graph of G. Now because point P is on the graph of G, we will substitute y with G at x. So every y value on this graph can be represented as f at x, and every y value on this graph can be represented as G at x. So we'll substitute y with G at x. So this is gonna be G at x. Now notice that G at x is this equation. So in place of G, we'll substitute this equation. So we're gonna write everything exactly the same except for this portion. Now notice that this is gonna be minus 2x squared plus 12x plus 4. So this is what we have so far. So we always have to write them in terms of the equation. So I've rewritten the coordinates in this form. So now the question says that you have to find the values of x such that this distance will be maximum. So basically we have to find the distance. Now you can use distance formula or you can use the shortcut. In this particular question, I'm going to use distance formula, and in the next question, I will use the shortcut. Now let's use distance formula. So now distance formula, notice that we're going to have d is equals to the square root of x2 minus x1. So then we have squared, then we're going to have y2 minus y1 squared. So now we have to substitute this stuff. So let's call this x1, or rather let's call it x2. So I'm just choosing to call it x2. Let's call this x2 and this x1. And let's call this one y2 and this one y1. So in order to create space, let me just write it over here. So now we've got the square root. And then now here we're going to have x minus x, right? Because that one is, so this x2, this x1. So we're going to have x minus x. So we have x minus x since they're exactly the same. And then let's substitute this particular portion. So this minus this. So we've got brackets, we've got negative 2x squared plus 12x plus 4. So now we are subtracting something that has got more than 2 terms, right? Whenever you are subtracting something with more than 2 terms, you have to put it in brackets. So we're going to say minus, then it's going to be 2x squared minus 8x minus 2. So this is going to be squared, so we're going to have squared. Yeah, so that's what we have. So let's go further. So now notice that this part is 0, so this part simply disappears. So now we're going to be left with the square root of this stuff. So we're going to have minus 2x squared plus 12x plus 4. And then we're going to have minus So we're going to have minus 2x squared minus 8x minus 2. So this is all squared. And now notice that since we've got only one bracket with a square, the square will cancel out the square root. So basically there's no need for brackets anymore. So the square will cancel with the square root. So let's proceed. So now this part, now we have to simplify it. So this is going to be minus 2x squared plus 12x plus 4. Then we're going to have, so let me just write it a bit better. So plus 4 minus 2x squared plus 8x plus 2. So then this part is going to be, so minus 2 and minus 2 will give us minus 4. So we've got minus 4x squared, and then 12 and 8 is 20. So we're going to have plus 20. So plus 20x. And then 4 and 2, that gives us 6. So we're going to have 6. So now we've got a quadratic equation. So we've found the distance, right? We've found the distance and we've simplified it. So whenever they ask you for maximum distance, you always have to find the distance and simplify it. Now, when they're asking for maximum distance, notice that this is actually a parabola. So I want you to notice something about this equation. Notice that this is a parabola. So if we were to draw it, you would realize that it's a parabola. So in other words, this parabola represents the distance. So it means the higher the graph, the higher the distance. But now we're looking for maximum distance. So the maximum distance is found at the turning point, because the turning point is the highest point in the whole graph. So for us to find maximum distance, because distance in this case represents a parabola, we have to find the y value of the turning point. So notice that we could tell that this was a frowning face parabola because of the value of a. The value of a is negative, so hence it's a frowning face parabola. If it was positive, we would have had a smiley face parabola. So the smiley face parabola has a minimum distance. So notice that it doesn't have maximum because it goes infinitely higher. So if it was a smiley faced parabola, they would have asked you for the minimum distance. So because this was a frowning face parabola, it has got a maximum distance, hence they asked you for maximum distance. There is no minimum distance because it goes infinitely low. So always remember, the maximum distance, whenever they ask you for the maximum distance, it's always found at the turning point of the parabola. So this will work if the distance is a quadratic equation. Sometimes the distance is not a quadratic equation. I'll show you that situation on the next question. So in order to find the maximum distance, we just need to find the y value of the turning point. So there are two methods to this. The first method is just to find the y value of the turning point, the normal way, and the second method is to use the derivative. I'm going to present both of them. If you have not been taught the derivative yet, you can use the first method, which I'm about to demonstrate. If you have been taught the derivative, you can use it because it's an advantage, because we do not always have a parabola. So the first method I'm going to show you is limited to the parabola. So only when distance is represented in the form of a parabola, we can use the first method. So let's go for the first method. So for the first method, you just have to find the x value of the turning point as normal. We know that in a parabola, the x value of the turning point is minus b over 2a. So then this is going to be x is equals to, so we're going to have minus, so what is our b? Our b is 20, so over 2a, so 2 times negative 4. And then this will literally give us x is equals to 10 over 4, I believe, which is actually 5 over 2. So notice that in this question, they didn't ask for the maximum distance. They only asked for the x value that will give us the maximum distance. So in this case, we have to stop here. But if they asked for the maximum distance, then the maximum distance is the y value of the turning point. So we would have to substitute it into the original equation of distance so that we can find the y value of the turning point. So since we've got the x value of the turning point, we need to substitute so that we can have the y value of the turning point. So that is how it is. So if we substitute it in place of x, we will get 31. So you can just verify that I did not use the calculator. So let's go for the second method. So for the second method, you have to use the derivative. So By the way, if you are doing grade 11 KEPS curriculum, you are not taught the derivative. So basically, when they ask you for maximum distance, you'll always be given a parabola. For those who are taught how to use the derivative, you might be given another form other than the parabola, where you'll be forced to use the first derivative. If you haven't yet learned how to derive and you'd like to learn how to derive, the video is right here on the top right of the screen. So let's proceed with the second method, which is the derivative. So we have to derive it. So we know that at the turning point, the first derivative is always 0. So the first derivative is always 0. So we have to find the first derivative. So then this is going to be minus 8x plus 20. So that's the first derivative. And we always have to tell them that the first derivative is 0 whenever you are finding the turning point or the x value of the turning point. So it means 0 is equals to minus 8x plus 20. So minus 8x plus 20. And then from there we're going to have 8x is equals to 20. And from here we have the same answer, 5 over 2. Or rather 5 over 4. So we have found the x value, and if they ask for the maximum distance, again we have to just take this and substitute it in place of x. So if they ask for the x value, this is where the answer ends. But if they ask for the actual maximum distance, we have to substitute this into the original equation so that we can find the maximum value. Alright, so now let's do a weird question. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvements. If you're interested in knowing the prices of the tutorials, the video that contains the prices and the updated contact details just in case these ones have changed is found at the end of this video. Alright, here is another question. So this particular question is taken from November 2014 past paper. So you're given two graphs. You're given a parabola which is g at x is equals to 4x squared minus 6. And you're given a root function which is the inverse of a parabola, which is f at x is equals to 2 root x. So in this particular question, they asked you to write down the length of QKT in terms of x, where x is the x coordinate of k. First of all, I want you to be aware that if they say the x coordinate of k, notice that this is a vertical line. Whenever we've got a vertical line, they're all sharing the same x coordinate. So all these 3 points are sharing the same x coordinate. So if we want to find the length of QKT, we just need to begin at Q and end at T. So notice that Q is a point on the Cartesian plane. Therefore, Q has an x coordinate and also a y coordinate. And T is also a point on the Cartesian plane, so it has an x coordinate and a y coordinate as well. So we'll do the same thing again. So notice that Q is on the graph f at x. So in place of the y value of Q, we're going to substitute it with f at x. And T is on the graph G. So in place of the y value of T, we're going to substitute it with g at x. So now f at x is equals to 2 root x. So f at x is the same as 2 root x. So we will write everything the same. It's just that we'll replace f at x with 2 root x. So we're going to say 2 root x. And g at x is equals to 4x squared minus 6. We will just write everything exactly the same, except that we're going to say 4x squared minus 6, because that is what g at x is equals to. So now notice that now we've got 2 points. So therefore we can find the distance. We can use distance formula or we can use the shortcut. So now what is the shortcut? Notice that whenever we've got a vertical line or a horizontal line, we do not necessarily need to calculate the distance using distance formula. We can use distance formula, but it's not necessary. For instance, if you're given a Cartesian plane and you're given a horizontal line, let's say this point is 8:2, and let's say this point is -4:2. Now notice that they've got the same y value because they're at the same height. These 2 points are at the same height. And when we're calculating distance, we just need to ignore the ones that are the same. So all we have to do is to just say d is equals to x2 minus x1. So we'll just say d is equals to the point that comes after minus the point that comes before. So it's going to be 8 minus -4. And then this is going to be 8 plus 4, which is 12. So the length is 12. Notice we did not need to use distance formula. So whenever you've got a horizontal line, all you need to do is just to say the later point minus the previous point. So what about if you're given a vertical line? Let's say you're given a vertical line, and let's say this is 2:4, and let's say this is 2:2 minus, let's say -8. So if you're asked to calculate the distance, notice that this time they are sharing the same x value because they are both on the same vertical plane. So when we're calculating the distance, all we need to do is to say d is equals to y2 minus y1. So we just have to say the y value that comes after subtracted by the y value that comes before. So it's always the larger one minus the smaller one. Now then this will become 4 minus -8. It's always the larger one minus the smaller one because distance can never be negative. So in this case, it's going to be 4 plus 8, which is going to be 12. So the distance is 12. So notice that we did not use distance formula. So whenever you've got a horizontal line or a vertical line, there is no need to use distance formula. Of course, you can use it, but it will be a long cut. Only when the line is diagonal, that's when it is a must to use distance formula. So notice these two coordinates. Notice that this is a vertical line, so there is no need to use the distance formula. You can use the distance formula as I did before, but we can use the shortcut. Now here I'm going to use the shortcut. Notice that they have got the same x values, so we can just ignore them. All we need to say is distance is equals to y2 minus y1 because it is vertical. Let's call this y2 and let's call this y1. Of course, the order does not matter. So this is going to be 2 root x minus. Now notice that if I'm subtracting something with more than one term, I have to put it in brackets. So then this is going to be 4x squared minus 6. So this is going to end up being 2 root x minus 4x squared plus 6. So let me just rearrange it so that it can start with the highest power. So then this is going to be 2 root x and this is going to be plus 6. So this is the higher power because this square root, if we change it into an exponential fraction, is the same as 1 over 2. So basically we've got 2x 1 over 2, so the highest power is this. But anyways, the order does not really matter. So we want to find the maximum distance. We've got a problem. The first problem we have is that this is not a parabola, so therefore we cannot find the turning point of the parabola as we did before. If it was a parabola, we would find the x value of the turning point by saying x is equals to minus b over 2a. And then from there, the answer that we would get, we would have to substitute it in place of x, and then we would get the actual maximum distance. But in this case, we cannot use the x value of the turning point because this is not a parabola. So we have to find the derivative of this stuff. The problem that we have at the moment is that this is not in a differentiable form. So let's first change it into a differentiable form. So if you want to learn how to derive, the video is found at the top right of the screen. So we have minus 4x squared, and then with this we're going to just change it into an exponential fraction. So we're going to have x to the power of 1 over 2. So we just change this into an exponential fraction so that this can be a differentiable form. It's always a differentiable form whenever we've got a x to the power of n. So whenever we've got a coefficient, a variable, and an exponent. So this is what we call a differentiable form. So we have plus 6. Now we can find the derivative since everything is in a differentiable form. Alright, let's derive this. So now when we derive this,
notice that we're going to have the first derivative. So this is going to be the first derivative. So if you want to learn how to derive, the video is at the top right of the screen. So this is going to give you 8. So we're going to have negative 8x when you minus 1. That's what we're going to have. We're going to literally be left with x. So now this side when you multiply, so we're going to have plus. So now when you multiply these two, notice that the 2 is going to cancel with the 2 at the bottom. So we're literally going to be left with x. And then when we subtract 1, we're going to be left with minus half. So we literally have minus half. Then we have, now notice that in terms of this part, the constant disappears always when we derive. So this is what we have. So we always have to tell them that the first derivative is equals to 0. So the first derivative at the turning point is always equals to 0. So we're going to say 0 is equals to negative 8x plus x to the power of negative half. So from here, notice that this can be changed into a fraction for the exponent to be positive. So let's solve it. So now we're going to have plus 1 over x to the power of half. So that's what we have. So how do we get rid of a fraction? So to get rid of a fraction when we're solving for x, we multiply everything by the LCD. So notice that this over 1, this over 1. So basically when you look at the denominator, the LCD is just x to the power of half. So we have to multiply everything by x to the power of half. So I'm going to say 0 times x to the power of half is equals to negative 8x times x to the power of half. And then from here I have plus 1 over x to the power of half times x to the power of half. So notice that I'm just multiplying everything by x to the power of half. So this part still gives us 0. And this part, notice that when the bases are the same, we have to add the exponents. So this x is to the power of 1 and this x is to the power of half. So we basically have to say 1 plus half, and 1 plus half is 1.5. So 1.5 is the same as 3 over 2. So we're going to say minus 8x to the power of 3 over 2. So this 3 over 2. So this is what we have so far. So now notice that this will actually cancel with the 1 at the denominator. So with this part, we're literally left with 1. So it means that we're going to have plus 1. So let's take this to the other side of the equation so that it can be positive. So now we're going to have 8x to the power of 3 over 2 is equals to 1. So now we can divide both sides by 8. So when you divide both sides by 8 is what we're left with. So we have x to the power of 3 over 2 is equals to 1 over 8.
So far this is what we have. Now when we break this is the same as 2 cubed. So there is 2 ways to solve it. We can solve it with the calculator. We can also solve it without the calculator. So I'm going to do it both ways. If we choose to solve it with the calculator, all we have to do is, in order to get rid of this exponent, we have to multiply both sides by the reciprocal. So notice that this whole thing has exponent 1. So this whole thing has exponent 1. So now we multiply both sides by the reciprocal. So then this is going to be times 2 over 3. So now notice whenever we multiply by the reciprocal, the exponents cancel out. And then we're going to be left with x is equals to. So this we have to type in the calculator. So when you type this in the calculator, you will end up getting your answer as x is equals to 1 over 4. So this is our answer. Now if you solve it without the calculator, we can choose to break this down. So let me solve it without the calculator. So we had x to the power of 3 over 2 is equals to 1 over 8. So this, when we break it, is the same as 2 cubed. So we're going to have 1 over 2 cubed. So far we've got x to the power of 3 over 2 is equals to this stuff. Now notice that x to the power of 3 over 2, this stuff, when you change it into a non-fraction, this is going to be 2 to the power of negative 3. So we have 2 to the power of negative 3. So notice this stuff. In order to get rid of the exponent, we have to multiply both sides by the reciprocal. So if we say times 2 over 3 on both sides, times 2 over 3, notice what will happen. We'll be left with x. But now on this side, we have it as negative 3 over 1. So notice that because these two are the same, they will cancel out. So this will cancel out. So basically we'll be left with 2 to the power of negative 2. So this, if you type it in a calculator again, or if you choose not to use the calculator, this is the same as 1 over 2 squared, which is the same as 1 over 4. So there we have it. So we have got a slight problem. The only problem is that this answer that we found is the x value that will give us the maximum distance. But they asked for the maximum distance, not the x value. They asked for the maximum distance. So in order to find the actual maximum distance, we have to substitute this into the original distance formula. So this is the original distance formula. So we got the x value such that the distance will be maximum. So we have to substitute this in place of x. So let's substitute it. If you substitute it, we're going to have minus 4, then we're going to have 1 over 4. So this you can literally type in the calculator. So I'm going to do it without the calculator. So then this is going to be plus 6. So let me do it without the calculator. So now this is going to be 1 over 16. And then this is this multiplied by this is literally going to be 1 over 4. And then this stuff is going to be 1 over 2. So times 2 is literally 1. So we're going to have plus 1 plus 6. So that is what we have. So this part is going to give us 3 over 4. Then we're going to have plus 6. So 6 plus 3 over 4 is the same as 6 and 3/4. So this when we convert it to an improper fraction, for 6 times 4 is 24 plus 3 is 27. So we literally have 27 over 4. Alright, you can verify this. So the answer to this was 27 over 4. So make sure that you know the difference between when they ask you for the x value that gives you the maximum distance and when they ask for the maximum distance. So if they ask you for the x value that gives you the maximum distance, your answer stops here. But if they ask for the actual maximum distance, you have to substitute into the original distance formula. And then the answer you get is your actual maximum distance. So there we have it. Alright, we have reached the end of this video. I have included a playlist of similar type of questions. If you enjoyed this video, please like the video and subscribe to my channel. Any questions you've got or any video you want me to create, please comment below. See you in the next video.